Welcome to Unit 3. Congratulations on making it all the way through limits. Now we're going to take everything that you learned in Unit 2 from 2.3 specifically about the power rule and apply it to more complicated functions to find the derivatives. Before we talk about why the product rule works, let's talk about why the product rule is necessary. So right now, if I asked you to find me the derivative of the function let's say 2x plus 1 times 3x. Well, you don't have a way to solve it as it is, but what you could do is distribute and get 6x squared plus 3x, and then you could easily find the derivative of that. So we could have 12x plus 3. No problem. What if I asked you to find the derivative of x plus 5 squared? Again, you could FOIL it out, write it out twice, then multiply it, and then take the derivative of that function using the power rule. However, what if I asked you for something a little bit more complicated? What if it looked like this? Now that's where we come into some trouble. We have two different functions, and I know the derivative of each piece of the functions, but I don't know the derivative altogether. I don't have a rule yet that tells me how to find the derivative altogether. Here, when it was algebra, this is algebraic, and this was algebraic, this is just multiplying, I was able to find these derivatives without much effort. But here, I'm a little bit stuck. That's what we're going to examine in this first part. So let me give you another example. F of x equals 2x times x cubed. In this case, our first function is 2x, and our second function is x cubed. So as you can see, capital F of x is the product of two functions, little f of x times little g of x. Next, I'm going to show you why the product rule works. This is not something that you need to memorize, or for that matter, even be able to reproduce. What you do need to be able to do for this is to just understand and follow along as I go. That's definitely the most important part about this proof, is that you're following along, not necessarily that you can reproduce it, and that you understand where the result comes from, because the result will become important from now until at least Christmas when we're doing derivatives. We're going to be using the limit formula of the derivative, which is the limit as h goes to 0, f of x plus h minus f of x all over h. That's the general form of the limit rule for the derivative. We're going to be using that now. So f prime of x is f of x plus h times g of x plus h minus f of x times g of x all over h. This next part involves adding and subtracting the same thing in order to make the formula look like something that we can use. So what I'm going to add and subtract, let's write this out again. We have f of x plus h times g of x plus h, and then I'm going to do minus f of x plus h times g of x plus f of x plus h times g of x, and then minus f of x g of x. So here what I've done is subtracted and added the same thing. So if I add 5 and subtract 5, it cancels out. So these terms would cancel, but I'm doing this specifically because I'm going to be using it in a minute. And this whole thing is over h. Now let's factor out our like terms. In this first part, we have f of x plus h and f of x plus h. So I have f of x plus h and then times g of x plus h minus g of x all over h. And then the second part, I have g of x that I can factor out. And I get f of x plus h minus f of x all over h. So in the limit rule, I should be taking this function as it goes to as limit as h goes to 0. I forgot to write that out, so I'm just going to squeeze that in. So let's take the limit as h goes to 0 of every single piece of this. So I'm just distributing that limit as h goes to 0 of every piece. And then we're going to independently let h go to 0. All right, so the limit as h goes to 0 of f of x plus h, well, this h will go to 0, so it will go away, and this will just become f of x. Now let's take a look at this part. Hopefully you recognize that as the limit formula that we wrote out here. So this one is just g prime of x plus, again, there's no h in this one, so it's just going to be g of x. And again, hopefully you recognize that as f prime times f prime of x. So the product rule is f of x times g prime of x plus g of x times f prime of x. This is super important, and on the next slide I'm going to summarize it for you. So if f and g are differentiable functions and f of x equals little f times little g, then capital F is differentiable and the derivative is f prime times g plus g prime times f. Now, a shorthand version of this is using u's and v's. So I want to do this problem out for you using the u's and v's of the problem 2x times x cubed. So we had one function times the other function. My u is my first function of 2x. My v is my second function of x cubed. Now we'll take the derivative of each piece. U prime, the derivative of 2x is 2, and v prime, the derivative of x cubed, is 3x squared. Now I'm going to use this formula, u prime times v, and I always make this little loop here to help me remember which two go first. Of course, in the product rule, it's addition, so it's not that important which two go first, but in the quotient rule, it's going to matter a lot, so I always just do it the same way so I don't make a mistake. So the derivative, f prime of x, is going to be u prime times v, or 2 times x cubed, and then plus the other two, 2x times 3x squared. So that's 2x cubed plus 6x cubed, or 8x cubed. And let's just prove that that's the same. If I had multiplied out the function to begin with, I would have gotten 2x to the 4th power. Then I would use my power rule to find my derivative. 2 times 4 is 8, and 4 minus 1 is 3, 8x cubed. And hopefully you notice that these are exactly the same. Here and here. Now, of course, when it's algebra, this is much easier to do, just multiplying it out to get the 2x to the 4th and not doing the product rule. But again, the functions will get more complicated, so we need to be able to solve them. Let's do another one. This is example 1 on page 194. We are going to do they want us to find y prime if y equals 1 plus x squared times e of x. Hopefully you notice that this is one function and here is my second function. Again, I will always use the shorthand u and v. You don't have to. The book uses f's and g's, but I will always use the shorthand because I think it's a little bit cleaner and quicker. But it's your call. You may use whatever you want. So I always set it up again just like this, 1 plus x squared, and then my v is e to the x, and then I write down my primes, or my derivatives. 1 plus x squared, the derivative is 2x. E to the x, the derivative is e to the x. Remember, that's that super special function where it's the only one that's the derivative of itself. And then I multiply those two together. It's 2x times e to the x plus, I multiply the other two, 1 plus x squared times e to the x. And I can leave it just like that. There is nothing else I need to do. I could do other things to simplify it, but I definitely don't have to. All right, let's do another one that's pretty tricky. First, we're going to do it using the product rule, and then we're going to multiply it out and show that we get the same thing. So hopefully, again, you see this piece is one function, and this piece is my other function. So my u is 5v squared minus v plus 1, and my v is v cubed minus 1. U prime is going to be 10v minus 1, and v prime is 3v squared. I multiply these two together. (10v minus 1) times v cubed minus 1 plus 3v squared times 5v squared minus v plus 1. Now, ordinarily, as I said, you could leave it just like this, but because they want us to be able to compare, we're going to have to FOIL it out and combine our like terms. So let's see, 10v to the fourth minus v cubed minus 10v plus 1 plus 15v to the fourth minus 3v cubed plus 3v squared. Looks like we have 25 v to the fourth minus 4v cubed plus 3v minus 10v plus 1. So that'll be my derivative. And now they want me to compare and see if that's the same thing as if I had FOILed first and then combined like terms, then took the derivative. So I think I'm running out of some room, so I'm going to write it up here. 5v to the fifth minus 5v squared minus v to the fourth plus v cubed minus 1. So all I've done right now is FOIL it out. Now let's take the derivative. Well, I'm going to do part B right here next to it. I should have written that this was part A. So 5 times 5, 25v minus 10v minus 4v, 25v to the fourth, minus 4v cubed plus 1 plus 3v squared. I'm going to write those in descending order. All right. So 25 v to the fourth minus 4v cubed plus 3v squared minus 10v plus 1. And I had noticed that I forgot to put this squared in. I wrote it here, but I forgot to write it here. So when I glanced down, I noticed that I had made a mistake. But now you see that they're exactly the same. The derivative is exactly the same whether you do it using the product rule or by multiplying using algebra. Again, it depends on how difficult the problem is which rule you'd like to use. So if you want to multiply and then use the prior rule, there's nothing wrong with that. But when the problem becomes more complicated, you don't have that option.